All right. So we talked about data types. We talked about numbers, text. We talked about booleans, which are also data types. We talked about complex numbers, and we moved on to data structures, where we talked about lists. We talked about tuples. We talked about dictionaries. We talked about sets, and then we move on to conditional statements, where we talked about the if-else statement, if statement, which are used to make decision based on a particular Boolean expression. So that's to say that if the expression meets the criteria, then we say that if that particular Boolean expression is true, then sometimes we made mention that the if statement always take the true statement. So if goes with true. So if true, then do something. Else, if it is not true, then the else statement comes. So every code that we want to put in the if statement will come, if the condition is true, should come under the if, and if the condition is false, should come under the else. Aside that, we also learn about looping. That is, looping has to do with how to, iterate through items within a data structure. So we realize that for data structures, they can contain more than a single data type or more than a single type of data type. So in this case, if we want to actually perform operation on each of the items, we use Python loops. So some of the keywords for the writing Python loops include the for loop and also the while loop. Okay, so we can put the conditional statement and then the looping statement together. So we can say that for the items within this particular data set, if it meets a particular condition, perform a particular operation on it or print it or do something with that particular data. So we were able to do that. And then we move on from that one to functions. Under functions, so we learned that if we want to write a code if we want to write a reproducible code or a reusable code, then we need to actually put it into a function. So in this case, a function helps us reuse the code over and over again. And we learned that if you want to define a function, you have to use the def keyword. So the def keyword and then the name of a function, and then you put into brackets. And if there is any parameter that you want to apply when calling the function, you put it. And then you define your function, what the function should do. And then we move on from that to data visualization, where we learn how to visualize data using the data structures that we've learned, the list that we've learned, and also the data that we stored in the form of a dictionary. And then so under the visualization, we did bar plots, scatter plots, histogram, and then we learned how to interpret those data, and we were able to do powerful visualizations. Additionally, also we learned about NumPy. In NumPy, we said that when you take a list can store multiple data types. A list can store an integer, it can store a float, it can store a boolean, okay, it can store a string. Now, when you take all these data types, because a list stores data in that way, each and every time Python checks the type of the data within a list before it continues with the operation that it would like to apply to it. But when you take a NumPy, Python do not consider any other data type. It considers only a single type of data, specifically numeric data types. So the word NumPy, I said it the other time, that comes from numeric Python, that it is used to perform high numerical computation. So when you have tons of numbers that you want to perform quick calculations on, NumPy is the best place to go. Today, we are going to talk about Pandas and how Pandas can help us actually work with data. So the advantage of Pandas is how voluminous of data that it can take. There are some volume of data that it will be impossible for you to store it in a dictionary or in a list, you are going to be overwhelmed by that. So Python provide the pandas which enables us to actually store data. All right, so one thing that I would like us to recall is that when we were doing the NumPy, we wrote a code like this. When we create a NumPy array, so when you say np, so first we need to import the NumPy array. So import, sorry, you need to import the NumPy. So import NumPy as np. Okay. So once we are done importing, we just run that code. Okay. So right, we have that working. So now we can perform some NumPy calculation. We realize that in NumPy we can have a 1D and a 2D NumPy array. So for a 1D NumPy array, what we do is that we create an array of lists. So say my underscore, just generate a code. Okay, so say my underscore numpy underscore array, meaning my numpy array. So you're going to say np.array. Then within the array, we pass on a list. So 1, 2, 3, 4. Okay, so when we run this, my underscore numpy array, once you run it, you see that now we have this particular list as an array, which is a NumPy array. And we say this one is one dimensional, but we can have a two-dimensional array whereby we have a list of lists. So in this case, we can have something like this. Okay, then we can have one like that. Okay, sorry. And then we can have two lists within that list. So you have 4 values. Let me say 5, 6, 7, 8. All right, so 5, 6, 7, 8. Okay. All right, so when you have something like this, we say it's a two-dimensional array. And the two-dimensional array, we have rows and then we have columns, if you guys will recall. Okay. So that's what we are saying, that Python pandas can be thought of as identified with labels rather than simple integers. All right, so in this case here, the position of each of these values are integers. So we have the index, but they don't have any label that you can say that this one is for something or this one is for other thing, as we could see in raw data. Okay, as we could see in raw data. It comes a limitation for raw data analysis or data presentation. So that limitation of NumPy is what Pandas capitalizes on. All right, so basically it is a structured way of building data structures. So NumPy came before Pandas. So Pandas has to fill in the gaps that NumPy couldn't fill. The array, but the positions of these values are all indexes. So provided I want to get the first row, I just need to say my underscore array, then at index position 0. So therefore, this particular one is supposed to be printed, or this one. Let's run that and see. Okay, so you see that I have that one. I have the first row, and the way I'm able to access that is implicitly by implicitly by providing an index value, but not a label. But with Pandas, you can provide a label instead of an index, and it will be able to access the values for you. All right. So let's move on to Pandas. So Pandas, like NumPy, is also an external package. And as a result of that, if Python wants to use it, we need to import it. So first, you need to install it by running. In your terminal, you can run, in your Jupyter terminal, you can run percentage pip install, then you say Pandas. Okay, so once you run this particular install, Python is going to install that for you, or you can use your terminal. So you can see the terminal over the PowerShell terminal. Once you wait for it to load, you can run the install command. Okay, so now it has loaded. So once it's done, yeah, sorry. So please, okay, so once the terminal comes, you can say pip install Pandas. Okay. So once you run pip install pandas, you realize that, wait, my terminal is misbehaving, by the way. Okay, it is coming out. So pip install pandas, just like that. Once you run it, pandas will be installed. And after that, you have to import it as pandas. So import pandas as PD. So this is just an alias name for the pandas. Or else, if we say import pandas alone, what we can do is that we will always have to write pandas instead of PD. So this short form saves some a little bit of typing. Okay, so when I run the pip install, the inline Jupyter command, you see that they said that requirements already satisfied. Why? Because I have the pandas already installed. And they're even showing me the directory where the pandas is. So yeah, this is the path. So this pandas, which is a package, is stored in the site packages. So when I go to this particular folder, I will find pandas there being installed. All right, so there's no need for me to install it again. Now, once I am done, when you take pandas on its own, it also has its own data structures because pandas handles data in a form of like an Excel spreadsheet. So what happens over here is that for every column of a pandas data, we call that column series. You see that when you pick an Excel sheet, so let me just show that Excel sheet with the data. So kindly bear with me as I switch this. All right, so I have the data here. So when you pick this particular column, as I've selected here let me just select it will have a better presentation. Okay. So I think this is okay. So once I select every column of this column as I selected in the Excel sheet, I don't have a name for it. However, in Excel sheet, I don't have a name, but when you see a data stored in a pandas like this, and this is how pandas stores data, we call this particular selected column, a pandas series. So this one will become a pandas series. This one also becomes a pandas series. This becomes a pandas series. So that is what I was showing initially in the data set. So we need to learn about the pandas data series so that we can learn how to modify it. Though the pandas series has some features that is like that of a NumPy single array, like a one-dimensional array. However, it has some features that are different from that. Let's see that in action. So you said that a pandas is a one-dimensional array of index data. Okay, so we can create that pandas from that panda series from a list. Now, how do we do that? Initially, when we want to create a NumPy array, we use np.array, where the np represents the NumPy that we imported. So we are using the np as its alias. So in this case, we are using the PD as alias for the pandas because without the PD, we have to call pandas. So let me just demonstrate that in a brief so that once we call that, we get to know. So you say pandas. Okay, so without the alias as something, we need to write pandas all the time, but that is kind of a lengthy thing. So we just use alias to help us. Okay. All right, so pd.series converts a list into a Python series. Now let's see this in action. I'm coming. Okay, good. So once we run, let's see. I think this one I have to import it again. Okay, good. All right, so let's see something. Initially, when you run a NumPy array on this, you just get an array. But when you say pd.series on a list, because what we have inside there is a list, you see that it returns a one-dimensional array of index data. So you have your list here, but the list has index data, and the index has been attached to it automatically. So that is a special case for a Pandas series. All right. So let's see. So with this, now we've studied to the variable data. So the data holds this particular expression, which is the pandas dot series 0.25 and values within your data set, not the index values. So let's do that and see. So once we run, you see that we have the data.values will print these particular values. And when you look at it, it looks more like a NumPy array. So maybe let's run the type to it, and let's, all right, so with the type, they tell you that it's a NumPy array. So you can see that with this particular expression, the the values within a Pandas series are actually NumPy arrays. However, the way the Pandas series handle it is different from ordinary NumPy arrays because it also provides its index implicitly. Okay, all right. So the values over here in the Pandas series are actually NumPy arrays. However, Pandas series add automatically these index which can be changed. So let's move on and let's see. So with the index, we have this. So we have a range index. So starting from, so we know that it starts from 0 to 3. So it just gives us the range. And this tells us the indexes. Instead of printing 0, 1, 2, 3, it just gives us the indexes, the range of the values that were provided. So if we add one value more to it, let's say 9.0, or let's say 9, to be converted to a float, because these particular values are a NumPy array. If there is a mixture of integers and then float, all integers will be converted to float. Okay, all right. So you can see that here the range has to change. Okay, so now the range has to change. So it has moved from 5. So this even tells you that there are 5 values there. Okay, so 0, 1, 2, 3, 4, 5. Because we know that the range has to start with, has a starting value 0, stopping value 5, but the 5 is not included because of Python's zero base indexing. And then the step is 1. So it's from 0, 1, 2, 3, 4. Okay. All right. So likewise, like NumPy array, you can do slicing or you can access the values within your Pandas series. What do? You just write the name of the variable that you've assigned to your Pandas series, and then you provide the index value as an argument in a square bracket, as we can see. So here 0.5. Why? Because the 0.5 is in the 1. Okay. All right, so we have some statements over here. So we said that the Pandas series, between a NumPy array and the Pandas series, is that the Pandas series has an explicitly defined index associated with the values. What that one means is that with the Pandas series, there is a definition of the index of the indices. Okay, of the indices. So the index is provided explicitly. What it implies is that when you have a NumPy array, you cannot add an index to values within a NumPy array. It's kind of a default, okay, and it's not mutable. But mutable means it cannot be changed. But with the Pandas series, you can provide your own index as to whichever way you want it to be. So let's see something over here. So from the first one, we created a Pandas series without providing any index, but this time we are creating a Pandas series with an index. So let's see. So data equals to pandas.series. Then we provided our lists, and in this case, the index we are providing it as an argument. And what should the index be? The index should be A, B, C, and then what? And D. So what it implies is that this A will be attached to this 0.25, B likewise, this, that, and this and that. So that is what we mean by the explicit definition of index values. But for NumPy, you cannot assign new values to the index. So as the numbers are, it has been indexed, and that is all. You can change it. Though there could be some times that you can change it, but however, in the case of pandas, how pandas is easy, and then you can change it to any value that cannot be seen in NumPy unless an extreme case, and it will involve a lot of code. So what you do is that when we run this particular code, you see that at position or index 0, okay, we have A. At index 0.5, we have B. At index 0.75, we have C. So instead of 0, 1, 2, 3, 4. So let's see, if now we have assigned new indices to these values, now we can access these values by their indices. Let's see how that's going to work. So when you say data B, so it means that we want to access the value B, the index B, we are getting 0.5. That is the same as the 1. So you can see that pandas.series, or the series data structure of pandas, allows you to have implicit, like explicit indices or index values. So these index values can be anything. So maybe it can be country or something, maybe some countries and their GDP or something. So instead of ABC, it can be country, which you cannot do in NumPy. All right. In other cases too, the indexes can be values. So let's see. So here we have the list as our values over here, which is the first argument. And then the second argument is the index. So this one, we need to specify it and then assign it to a list of values. When we run this particular code, you see that these 2, 5, 3, 7 has now become the indices of the Python list, the values in the Python list. So in this case, if I want to access 1, I can say data then 7, because at index 7, the value is 1. Let's see what I'll get. So I get 1.0. Likewise, I can do for all of them. Let's say I want to access 0.75. The value there is 3. So I'm getting the 0.75. This dynamic nature of Pandas series actually allows us to access rows in a particular data frame by numbers or by labels. So here you see that we are using numbers, and if you don't provide the index at all, Python will use a default indexing. So let me just delete that and let's see that one in action. So it uses a default indexing as in 0, 1, 2, 3. But once you provide an index, Python inherits this new index that you've created. So by default, it's the natural one. But if you provide, Python will inherit that one. That functionality is not present in NumPy, making Pandas a top-notch. All right. So now we've talked about Pandas data series as NumPy arrays. We can also talk of Pandas data series as dictionary, okay, or specialized dictionary. Now, when you take a dictionary, for instance, let's see this particular dictionary. So we have a population dictionary. So California, Texas, and then New York, and Florida, and then Illinois. So when you take these particular country cities and their respective population, this is how a dictionary looks like. And ideally, in a dictionary, if I want to access the values over here, I need to use the keys as an argument. So if I want to actually access the population of New York, ideally I have to write something like population underscore dict. Then I pass the New York. Sorry, I said Florida. Okay, let me use Florida. So I'll pass the Florida as an argument. Let me just comment this one and let's see something. So once I run this, you see that now the population of Florida, which is the 19, and the rest of the numbers is what is showing over here. Okay, and we are saying that you can see series as specialized dictionary. How is that so? Let me comment that and then let's run this code to see what that implies. Good. So over here, when we pass on the population dict, which is the dictionary of these keys and value pairs, into our pandas.series, what happens is that these become the index of these values. Instead of keys, they become index of these values. And the index are crucial because in a whole data frame, as I showed you in the Excel sheet, we work as in rows and columns. And if we are working rows and columns, we don't need to have that kind of a key and its value. We need indexes, okay, and their values. All right, so what Python pandas.series does is that it converts this dictionary, sorry, it converts this dictionary into into it converts this dictionary from key and value pairs into indexes and then their values. Okay. And this is crucial because of some of the operations that you would like to perform in a whole table other than a simple dictionary, because the information that the dictionary can contain is limited also to some extent. So from the beginning to this end, we can say that you can create Pandas series from a list and you can create Pandas series from a dictionary. However, you will realize that the values are always NumPy arrays. Okay, so we can try that here by writing type. So with this type, we say population dot index, sorry, values. Okay. Okay, so you can see that it's NumPy ND array. So these values over here are NumPy arrays. That is why when you have a tabular data, the calculation is very fast. So what Pandas does is that it indexes these values. However, the values are still NumPy arrays. So Pandas series are more of like NumPy arrays with an index that you can modify by yourself or you can create by yourself explicitly. All right, so let's see. So we want to assess the values of California. So you said that by default, a series will be created where the index is drawn from the sorted arrays. From here, typical dictionary star item access can be performed. However, though we are accessing the value of California over here, we are not doing key value pair, but we are doing indexes in their values. So once you do that, you are going to have this value from California, which is similar to how we assess values from using how do we call it, like the square bracket. So you can see that even how we are accessing data, it has been like consistent throughout. All of them, we need a square bracket. Yeah. So, okay, let me move on. So, unlike a dictionary, for a dictionary, because it's a key value pair, you cannot select a range. But because Pandas series creates an index and then its values, you can select a range. Because in the indices always allows us to select a range. If you recall when we were learning the NumPy array, you see that there are times that we can select a particular segment using slicing. Let's perform one over here. So here we are using the population, which is our Pandas series. And from this particular thing, what we want to do is that we want to slice the cities from California to Illinois. So when we do this, what you're going to get is that the cities between them has been provided, their values has been provided. But if you have a raw dictionary, you can't do that. So let's try that with our dictionary. So we say population underscore dict. So population underscore dict, and then let's say we say let's say Texas to Florida. Okay. Florida. Okay. let's see what will happen. Mhm. So you see that on hashable type slice, what it means is that for a dictionary, because it is a key and its value, you cannot slice values. But once you convert that dictionary to a Pandas series, you have index and values. With indexes, you can slice indexes. That makes it possible for us to slice from California to Illinois in this particular data set. So we provide the slicing over here. So start from California and then end at Illinois. Now you can see that over here, we are not using the zero and then the ones. We are using the labels, which are the the indexes over here that we've provided. So ideally, when you have a dictionary and you converted it into a Pandas series, the keys becomes the indexes and then the values becomes the values of that particular Pandas series. Okay, so you can also create pandas from a list. So with this, you create a list, then you have, it will label it automatically for you, provided we want to modify it to and provide an index. You can say index equals to, and we provide a list of the values or maybe name, maybe first person should be Amma, the second person should be Kofi, and then the third person should be Joe. Okay, so with this, when we do that, you can see that now the indexes have been replaced with these AMA n. If I want to access them, I can say, let me assign it to a value, a variable called maybe student children underscore health underscore quality. Okay, so maybe this records the health quality of students. Okay, so once you do that, okay, I have to just run the children. Okay, so we can access the values of each of them with these particular labels that we provided as indices. So you can see children have score. I want that of Amma. So Amma's own will be provided. I want that of Joe. Joe's own will be provided. I want to slice from Amma to Joe. So that will be, so Amma to Joe, have to slice and say Joe. So it has printed all of them for me. Okay. All right. So basically that's Pandas series. So here what you can do is that you can assign many indices to one value. So here we want to assign these indexes 100, 200, and 300 to the value 5. So you can see that you have indexes of 100, 200, 500 to a single value 5. And here in dictionary, we've learned about it already. So here the 2, which is the key, will become the indices, and then the A, B, C will become the values. So once we do that, so 2, 1, 3, and it can be any other form because your index shouldn't be always 0, 1, 2, 3, because in raw data set, that is not what it's saying. That is not what it's saying. Okay. All right. So basically, we are done with Pandas data series. And as I said earlier, the Pandas data series is like this part of an Excel sheet. So it's like this, okay? So when you pick one particular column of any data in a Pandas data frame, that is called a Pandas series. So that particular data has indices, and then it has values. So if this is to be a Pandas data frame, and this single one we are saying that it's called a series, then what we are implying or suggesting or trying to say is that this particular data set, which has the 99, the active, which has a the column name active actually has indexes. So 0, 1, 2, 3, but it is not showing here. And we can assign any index to it. That is how come you can put these and these two together. So you can put these two together, whereby these become the indexes for these particular values. Please, you get it? Do you get the rationale? So if Pandas is not able to have indices for each of the rows, you cannot make any other column an index for this in order to access the values. So in this case here, if I want to find the values for the number of active cases for Afghanistan, I don't have to know the value index of this. I just can run this Afghanistan and then have to get this. So that is how Pandas treat data, so that using a particular index, you can access various data sets or data types. Okay, so here it is appearing as an object. So basically, these are strings, right? A, B, C, D, R. So in the encoding form, you know that numbers too are they are integers or floats, right? But when you use NumPy, it is being stored as integer 64. So all these strings, when you are using Pandas or NumPy, they consider these data types as what? Objects. So it's the same as the strings, but they consider it as objects. But as to the reason why they consider it as objects, I have not figured it out yet. But it stores it as object, which is the same as the string that we know. So it implies that when you are working in Pandas, when you see any data type that is an object, it tells you that the values within that particular column or that particular data, they are what? Strings. Okay. Yes, please. Okay, please, any question? Any other question? Okay, if there is none, then let's make progress. All right, so I have a brief note over here, which you can read to help build your intuition. So we've learned how to build Pandas series from a dictionary. However, Pandas also have another data structure aside the series called data frame. Okay. All right. So the data frame is a two-dimensional labeled table, exactly like a spreadsheet in Excel. So the Excel that we saw, that is how a data frame works. Okay. And it looks like more of like a database too, whichever way that you like to take it. So every column has a name, every row has an index, and every column can hold a different data type. Now you can you realize that every column has a name, every row has an index. So in a data frame, there should always be an index. That's why when we were working with pandas.series, which we say that they represent each column of every data frame, once you run it, you are going to have an index and then the values. This is because in Pandas data frame, every row should have an index because you are going to access the values with the index. Okay. All right. As I think once we go through some examples, we will get to know. So let's consider this particular list of dictionaries over here. So we have different dictionaries. Okay. So these dictionaries can represent like a data that we collected. So country Ghana, confirmed cases, maybe because we are going to use the COVID data. Okay. So country Ghana, confirmed cases, deaths, people who have recovered, and then the region is Africa. Then we are taking the next Nigeria, Kenya. So these are data that we've taken and we've stored them as list of dictionaries. Each dictionary over here represents a role in a data. Okay, each dictionary represents a role. Okay, and then each of these keys, each of the keys over here represents a column. So in this case, if we want to get each of the items over here, we just need to write for loop. So for role in countries raw, print row, so it's going to print each of the values over here. Okay. But let's see something over here. Now we've imported the pandas already, so we don't need to import it again. So we are going to convert this particular dictionary into a pandas data frame, and we will see how the data will be presented. How do we convert that to a pandas data frame? We use the pd.data frame, and then we provide the name of the list of dictionaries as an argument to the data frame function. So once we do that, the dictionary will be converted into a pandas data frame, which is like the Excel sheet that we've seen already. So let's see that in action. Okay, so you will realize that in this case, we have, instead of the data being presented like this, okay, now we have the data being presented like this. So you see that the country is here, and then you have Ghana, Nigeria, Kenya, and then you have confirmed cases. So Ghana, the confirmed cases, and so on and so forth. Please, I hope you can see that. And then because every row is indexed, pandas give it an automatic index because we have not provided any index for it. So the indexes are 0, 1, 2, 3. So if you want to access the value, as in country, Ghana, confirmed cases, death, recovered, and then who region, all of them will be WHO, sorry, the WHO region, all of them will be provided. Okay. All right. So let's see. So this is just a way of converting a dictionary to a pandas data frame. Very simple. So each time you have a dictionary, you can convert it into a tabular like form like this, like what you're seeing over here, using the pandas or data frame. However, this is a way of just transforming a dictionary into a pandas data frame. So what of tons of data? Okay, the data is a lot, and you can't use a dictionary as a reliable means of storing your data, voluminous data. You'll be bored. Okay, so what you do is that we use, like, let's say we store data in the form of like a CSV or an Excel file. So you can still convert an Excel file into a pandas data frame, but today we are going to stick with the CSV. The CSV stands for the comma separated values. So when you look at the Excel sheet that we provided over here, so when you look at the Excel sheets we have over here, so the data over here, when you go to the, sorry, file, then you come to save as, okay, whichever way, maybe desktop. I'm not saving though, but I want to show you something. So you see that the save as type, so that when you click on it, you have different types of, different ways that you can save this particular document. So one way that you can save is as a comma delimited or comma separated values. And then you can also save it as an Excel workbook or Excel sheet. So whichever way you store it, you can import it in pandas. Okay. All right. So how do you do that in pandas? That's what we are going to take a look at. Okay. So in pandas, if I want to read a CSV file, the function that I want to do is to pd.csv into brackets. So the bracket over here, what will be part to the file on my PC. Okay, so let's see that's in action. So you said that import. So since we've imported the pandas, we don't have to be importing it over and over again. So what I'm going to do is that I'm going to create a variable called df. The df can stand for data frame, but mostly you use a name that is more that describes your data, because when you use df, it gets a time that you might not know. So maybe I can say corona data. Okay, yes, so corona data underscore data. Okay, corona. Okay, corona data. So let's say this. So I need to change this one to corona. Okay. All right. So corona data. So what happens is that I am I'm saying that pandas should read. So use this CSV read CSV function should read the file in this particular directory. Okay. So when I open my file explorer and you can see that it's just a path leading to that particular file. So desktop, the folder practice, go to under the folder practice, go to data. Under the data, go to coronavirus. Under the coronavirus, we have a file called countrywise latest.csv, okay, which is the data of the file that contains the data that we want to work on. So you can get this by just right clicking on the data. So let me show you how you can get the path easily. Okay, so here, this is my path. Okay, so when you see that this is the path, user desktop practice coronavirus. So if I want to get the path of this, I right click here. Okay, so that copy as path over here. Okay, so you copy it as path. Now, one thing that you have to know is that after you've copied it as path, you just have to paste it. So you need to paste it here. Now, let me just demonstrate something over here. So okay, all right. So what I was saying is that if you want to load the data in Pandas, you need to get the path of the data. Okay, the path is where is that data? Where can I find the data? Because the function that you are writing, the function over here is telling Pandas that I want to read a CSV file. And what CSV file do you want to read? Okay, so you are telling Pandas that look at this particular file path for that particular CSV file that I want you to read. So how do you get it? That was what I was showing. So you go here and then you say share the screen. So once you share this, so once you are here, what you do is that you right click on the data that you want to use. Okay, then you come to copy as path. So once you click on copy as path, the file path has been copied. Provided I want to use a different data, maybe diabetes data, I can just right click on that and copy as path. That one will be copied. Okay, so let's do the first one. Once we are done, I will change it so that we see how it works. So all that you are telling Pandas is that I want you to read a CSV file, but Pandas also want to know which CSV file you want to read. So you need to provide the path on your computer to it, and then it will read that one for you automatically. Please, do we get it? All right, so once you have the file, this is how it looks like. But you see that Python, when you have a forward slashes like that in your path, Python cannot read it. So you bring this R value over here, which reverses this one into a backward slash. That is what Python can read. That's why I have provided a little R over here to reverse all these slashes, or else you get an error. So let's try that and see. So provided this one is no longer there. Okay, so when I do Control V and then I paste a path over there. Okay, let me just comment this one and let's run. Okay, is it a corona data? See that Unicode escape codec can't decode byte in position 2, 3 truncated. So it's all because of this particular forward slashes are used for line breaks. So once you provide this, Python treats it as line breaks. So you use the R to reverse it into its alternative form. So actually what works is this particular slash. Okay, I think that's the forward slash, right? It's confusing me, but I hope you are trying to you get what I'm trying to say. And so we need these ones, but when you copy the path, it's in this way. But changing each of them is difficult. So we use the R to convert them automatically. Let's run and see. So see that this time there is no error. So we can continue with our code. So once you run, you see the data loaded successfully. And then when you check for the class, the type of this particular data, it will tell you that it is a Pandas data frame. Okay, Pandas data frame, which is like an Excel sheet. So we are going to view the data and then we will see how it looks like. So before we get to this place, we can view the data by just running or calling the corona data value. So the corona underscore data. So you see how the data has been presented. So you have columns and you have your rows, similar to what we saw in the Excel sheet. So similar to what we saw in the Excel sheet over here. So you can see that it's the same thing. The same thing. So you see that Excel 2 has some index, like some index values over here, starting from 1. And then you see your data arranged in columns like that. It's the same thing that we are seeing in our Pandas data frame. So once you load it, you can do whatever you want to do with it. So it's like an Excel sheet, but a programmable Excel sheet. Yeah, so let's put it that way. So Excel sheet that is programmable. So you have country, region. So these dots tells you that the data is voluminous and it cannot print everything. So these dots means that some data is between from the position 4 to the 182. There are data in between. Okay, so basically that is how the pandas.data frame, the data frame treat data. So it treats data as just like an Excel sheet, but this one is highly programmable and highly customizable. But instead of in Excel, you are going to click. That's why you have to write a script to do what you want to do. All right, so we have a function called so because I use the df, which is the data frame to do all the rest, unless I have to change them manually. So I'm just going to, for the sake of removing fast, I'm just making a df, but it can be anything and it should describe your data. So df, I need to call that. Okay. I need to call this. All right, so it should be working now. Okay, so df, then remove. So here you can just, maybe you don't want to view all the data, you want to just see how the data looks like. You can use the head, okay? So the head retrieves the first 5 rows. So 0, 1, 2, 3. So you see that you have the first 5 rows over here. Very beautiful. And then you can provide, maybe you can specify an argument within the dot head. So the head is a method for the df, for the data frame. So maybe you want to just retrieve the first 10 data to look at the data, have a view of the data. Okay, so what that data entails, what are the values there? Just your eyes skimming through the data to know what is there. And likewise, you can also look at the tail. So how is the tail of the data looks like? So this is very crucial in data analysis, because sometimes the data that will be collected, before you can perform analysis on, you have to just know the structure. And sometimes maybe at the tail of the data, maybe the people did lazy work, so there is a lot of missing values. You can also know and then tell the person that, oh, looking at the structure of the data, it doesn't have a lot, or there are lots of missing values. So maybe you will see what you can do. Or maybe the data has to be collected, provided there is a chance. So you can also see the tail, which is the last values. So you see that the head prints the values from 0 to the number that we specified, the 10, which is the first 10 values. And the tail also retrieves the last 5 values. And I think that once you can pass an argument into it. So the last n rows, so maybe the last 10 rows, it will print the last 10 rows. Okay. All right. So that is that for how to have a view of your data. So first, you can just run your df direct, or you can use the dot head or dot tail to view the data. Another thing that you can also do is to figure out the number of rows and columns that you have in your data. How do you get to know that? We use the dot shape method. The dot-shape method returns a tuple. So if you recall in Pandas, when you use the dot-shape method on a 2D array, it returns the number of rows and columns. Likewise, the same thing happens over here. So when you run the dot-shape method, it gives you, a tuple. So you have a tuple of your rows and columns. So the number of rows is the first and the number of columns is the second. So because this one will return a tuple, we can index it. That's why we are using the 0 index and then the 1 index. So it's more of like you have this tuple and you want to index it, as we know already. No any new formulation. So this tells you that the number of rows are 87 and then the number of columns are 15. So our data has 15 rows and 15 columns, 187 rows. So this is what we call data exploration. You are learning about your data, because before you can perform an analysis as an analyst, you need to know your data. What is there? What volume of data is there? And how many columns are there? Okay. That's interesting. So once you are done, you can also print the columns. So what are the columns? So now we know that we have 15 columns. What are the columns? What are the labels for those columns? So you can do that by using the dot columns, which is a method. So you say that the data frame or the data frame that you've created, dot columns. And here we are using the to list so that it will convert these columns, the columns in our data, to a list, a Python list, the ordinary list that we all know. So let's see that in action. All right, so you see that we have a list over here. So first square bracket, so a list over here that prints all the 15 columns that we have, but just it doesn't just print anything, but it prints the names. So you can say that, okay, so the data contains the country origin, confirmed, deaths, recovered, active, new cases, new deaths, new recovered, deaths over 100 cases. So I think this one we just maybe want to calculate the rate of death, and then the rate of recovery. Okay, and so on and so forth. So it tells you, it gives you a fair knowledge of what data is there and what columns are also there. Okay, so these are data exploration. And then you can also check for the data types of the data of the columns in your data. So we say that we have each column. Those columns are Pandas series. But when different Pandas series comes together, it forms the data frame. And data frame is like an Excel sheet. And we need to explore our data to know what is there. So the D types method, what it does is that it's able to check for every column and tell you what data type is there. All right, so all strings, as I said earlier, or text data will be stored as objects. And then you find floats as float 64 and the integers as integer 64. All right, so let's see that one in action. Okay, so these are our 15 columns. So it tells you that the first column, country or region, is object. So they are strings. Confirmed cases are integers. These are that, and that, and that, and that. So it gives you all the data types. So integers and floats we know already. And then objects we know. So the WHO region is also a text or a string. So this tells you that, okay, so now I cannot use the country or region for calculation or this for calculation because they are objects and we can't use strings for calculation. But the rest, I can use them for calculation. So it tells you what data types are there. And you just use the D types on your data frame. Okay, so there is also another important function over here. So this function is called the .info. So when you run the .info on your data frame, what happens is that it retrieves every crucial information that you need to know about your data. So we are still in the process of the data exploration. So when we run the dt.info, it tells us what data is there, the data type, and whether there are missing values or there are no missing values. All right, so and it gives you a brief about the data. So you know that most of the things that we've run individually have all been put together in the info session. So it tells you that the data type of the data that we are viewing is a pandas data frame over here. And then the range, it says that there are 187 entries. So this tells you the number of data that is there or the number of rows that is there, 187. 0 to 186. The reason why it's 0 to 186 is because of the zero base indexing. Okay, and the count has to tells you the number of non-missing values. So when you look at it, you can see that the 187, all these values are 187. So it tells you that there are no missing values within our data set. So when by this information, you can say that, okay, the data was taken well because there are no missing values. And based on just this, it can tell you whether you have to check for missing values or you don't have to check for missing values. Okay. All right. So that is for the info. We also have the dot describe method or the dot describe function. What it does is that it retrieves the descriptive statistics. So first, what we were doing is the data exploration, and as part of the data exploration is what we call the descriptive statistics, which has to do with the mean, mode, median, percentiles. So the describe method also does that. How do you get that? Instead of writing the standard deviation and everything, you just use the df that describe, and then it tells you about the descriptive statistics of the data. So you can see, let's see the presentation. So it picks each of the columns, so they're confirmed. And basically these things are performed on, please give me a moment. So basically these statistical descriptive statistics require numeric values. So you cannot see the country over here. Neither can you see also the WHO region because those are objects. But the float and then the integers, Python is going to calculate the number of counts. So the number of count, the count, the mean, the standard deviation, the minimum value, the 20th percentile, 50th percentile, 75th percentile, and then the maximum value. For all the columns that have numeric and that have integers or float data types. So by this, you can learn of your data. So you know that there are times that the data can be off. Let's say provided is a diabetes data. And let's say the maximum value, when you check for the maximum value is so high, like beyond the threshold. You know that no, something is wrong with that data. That one will be an outlier. Okay, so it all helps you to prepare how you are going to analyze your data in order to get the most out of it. Okay, so the reason why here, even for the number of counts, it comes in decimals, is because this is more of like a data that was prepared for a machine learning. Okay, so some of the values are in decimal forms because sometimes we scale in machine learning, the data has to, some algorithms requires that the data has to be scaled for effective performance. So here, in this case, because the decimals are many, it makes reading the data difficult. You can use our old friend, the round function, to convert all decimal values to two decimal places. And then we have that. So beautiful. Okay. All right. All right. So that is that. So, I mean, I think when it comes to 2 decimal places, it's more cool because now you can see the counts very well. 187, 187, 187. Yes. And then the mean value, and then that's, you can get to know all of them. Okay, so up to this stage, please, if you have, using it is very simple. Very, very simple. So right now you've been able to perform a very real time, or let me put it this way. So real life data analysis. Every data analyst every day has to explore the data. Even in machine learning, you have to explore the data. So it's cut across all working places with data. So if you want to work with data, all these things are crucial. And your ability to interpret them well can also inform how your data value should be. Okay. All right. So from here, based on the minimum value, you can say that there were days or times that there were no death cases recorded. But it looks like there was no day that confirmed cases was not discovered, because the least or the minimum value of the confirmed cases is 10. Okay, so you see that by this is an insight about the data. So that is that. Okay. So with this, we can move on to selecting rows and columns. And we will end the session for today under this subtopic. So if data is in the form of rows and columns, as we have all seen with our eyes, so let me try and then call the entire data so that we see. All right, so let me call the DF. Let's see. Okay. Let's see the country region. Those are the columns. Then we have our rows over here. Now, we want to, provided we want to access only the values of confirmed cases. How do we do that? Let's see. Very simple. When we were working with like the previous data types, like NumPy, dictionary, and everything, if we want to select a particular data, what we do is that we provide that particular data as an argument. So in this case, if you want to select only the confirmed cases, what we have to do in cases, because once we do that, it will extract all the values from this particular column. Okay, so let's see. Okay, so you can see that here we have those values extracted. So let's just compare. So 3, 6, whatever, and then you have that 3, 6, whatever. By the way, and then when you check for the type, you see that it's a Pandas series, isn't it? The series that we've talked about. So because they are Pandas series, you see that the indices has come, or the index has come. Okay, and we can change this index to whatever we want and work with this particular data alone, or this particular column alone. Okay, all right. So here we just printed only the first 10 by using the dot head. Okay, so we can also do the same for the dev/100 cases. So you see that in our columns, let me just bring the columns so that I will not be going back. So you see that df.columns, I'm not tying it to a list. Okay, so in our columns, that mean the column names, that we have deaths over 100 cases. Okay, so the death over 100 cases, we can extract that particular column also here. Okay, and because we are not providing any this thing, any arguments for the or any value for the head, it prints the first five. So it means that we can practically extract all the data, and every column within this particular data is called a Pandas series. Okay. Even though it's a Pandas series, the actual values are NumPy arrays. Okay. So once we are done, we can move on to see other things. What of we selecting multiple columns? That is also possible. But however, to select multiple columns, because the columns are multiple, we pass them as a list. So here we create a list for all the columns that we want to. And then we slice those lists, or we pass those lists as an argument within the data frame. So initially, if we want one, we are saying that df, then we bring our square bracket, and then we provide the name of the column there. But if you want many, the many becomes like more than one data type. So we need to put it in a good data structure. And in this case, the acceptable data structure is a list. So you can see that here we have two brackets over here. It shouldn't be any problem at all. It's just we are passing a list of values within our index values. So the list of values, we have the country origin, confirmed cases, confirmed deaths, recovered and active. So this will print the key columns, okay, and then the first 10 of it because of the death. Okay, let's see. So you see that the entire data, we have selected a portion of the data, and you can work with with only this particular data, provided that is what you want to work with. Maybe with this, you can also perform visualizations. Okay, so yeah, maybe we can do a bar chart. So with the bar chart, we see the bar chart and then the number of deaths to see which country records the highest death, which country records the lowest death. Simply by using the matplotlib. So with that, we need to let's import from matplotlib, import matplotlib dot p dot pyplot as plt, right? Okay, so matplotlib is imported, and then we just need to specify our figure and then access. This is just some sample something that I'm doing. See, so plt dot subplot. Okay, let me say the fixed size. Say maybe 8 by 10. Should be multiple. So 8 by 10. Okay. Then we say ax dot bar. Okay. What should the x-axis be? So the x-axis, we want the country region. So we are going to say df. Then we say here country region. Okay. Then what should our y-axis be? So the y-axis should be the depth. So df. The depth. Okay. Simple. I'm not going to add anything. So I'm just going to say plt dot tight. For this one, I'm not even using any label, so plt show. Okay, good. Let's see that. There's some simple plot to see how the data is going to work. Okay, there is an error. Let me see. Fixed size. let's unpack on iTravel access. Okay, come. Okay, so the fourth has to do with the subplots. Fixed size. Okay. Okay, so we have that. So let me just specify. So 10, maybe 8. Okay. And this one should be working. Okay, so though it's not displaying much more clear because there is a lot of um, the country region, so different countries. Okay, WHO region. I think that one would be better. WHO region. How's that one? Let me just check for the column name. So WHO region. So region. Okay, I think this one should be working. Okay, so now you see that this is just a simple plot. Okay, we can to send all those stuffs, but I mean, so you can see that with this with this visualization, we can see the number of death cases across the different continents. So you can see that from this, American recorded the highest death cases. Okay, Africa. Okay, Western Pacific, the least. From the Africa, then Eastern Mediterranean, then Southeast Asia, then Europe. Please, can you see it? So that's very interesting. So first, we were using NumPy arrays, or we were using lists. In this case, we are using Pandas series. Okay, to make it it's the plot is very nice. X-axis, Y-axis, so we can specify other things, as in the color and all those parameters. Okay, but I don't need that at the moment, so that's why I just need this basic plot. Though it looks basic, but very informative. Okay, so you can do that for maybe confirmed cases. Okay, so confirmed cases, let's say confirmed cases. Confirmed. Let me see the name well. Because if you don't provide the right name to Pandas will give you an error. So your column name should always be accurate. So the confirmed cases too, we see that of American is the highest. Africa now beats Eastern Mediterranean, and then Western Pacific still remains the least. Southeast Asia also be just using this plot particular thing, so that the names that you provide here will be arguments, which I'm not going to do at the moment. Okay, so we can. Okay. So maybe you want to select a particular variables or particular columns to analyze in your data. You can select them and give them a variable. So now instead of working with BF, you work with only these particular values. So these how you can select multiple columns or single columns and work with them. So I'm ending here. When we meet on, so I'm owing you one. So I want to put that one on that before we meet on Sunday. Notebook where we've got into. So with the data too, I'll add the data to it so that you can install the data on your local machine, copy the path and put the path inside as your argument, and then you can also explore the data. And I also added another link to it where you can go and download any data that you like to explore and then work with. So you can perform some of these visualizations. Yeah, so I also saw that over the weekend, I saw Grace posting some wonderful visualizations on LinkedIn. So please, it's very crucial. So do that and sell yourself. Do that and sell yourself. People don't have what you are having. So if what you have, you don't sell it, people who don't have what you have will sell theirs and then they will have a point. So please, let's do also the visualizations. Once you are practicing, make sure you put it there. Let the people know what you are doing. Even if it is small, let them know. It goes a long way to influence you. Now, you cannot apply anything without adding your LinkedIn, this one, account link. So when they go there, what are they seeing? They are seeing nothing. But if they are seeing some activity, they know that, oh, you have been spending your time wisely. And what you said you can do, you have actually been practicing, showing that you are a good candidate for that particular office. Okay. All right. So that is that for today.